All right, so I just wanted to take a quick moment to introduce you to some of the materials that you're going to be using on this lab. This first object right here is a spring scale, and a spring scale is very simple. It's got hooks. You pull on the hook, and it measures the force. This, as you can see, is a 5 Newton spring scale. So please do not exceed a 5 Newton force because you will break it. And these, believe it or not, are $20 a piece. But what we're going to do with these is I have the block here that's got the felt on the bottom, and I want to determine the coefficient of friction on the felt on the table. So all I do is I take my spring scale and I hook it up, and if I'm far enough away I can see this, but I'll pull on it until it starts to move. Okay? Now let me get a little closer and examine what's going on. So as I hook this up, right now I'm just pulling and the object is not moving yet. And then you saw right there that it did start to move, okay? So as it's pulling, I reach the maximum static friction, and then as I exceed that, it moves. So for this, my maximum force of static friction is right around 3.5 newtons, okay? So that's how I'm gonna use that to fill out the table. Then I have to look and see, okay, now it's moving. What is it moving at? So if I back it up and do it again, all I have to do is watch it's at a constant velocity. I'm right around 2.5 newtons. So my maximum force of static friction was 3.5 newtons. So it made it all the way to there. But then when it was at constant speed, it dropped down to 2.5 newtons. So I'm going to use these two values to fill in my data table that I'll talk about in the lab video. But that was a quick introduction to spring scales and how we're going to use it to do this lab. Now the mass itself, you can vary to make it easier. I added these two masses so that I could have a more resistive force that was easier to measure. But good luck in your procedure.